In this video, we introduce authoring constraints with the Newton Dynamics plugin for Unreal. We define a rigid body constraint as the operation of restricting the relative motion between two rigid bodies in one or more degrees of freedom. Examples of simple constraints are hinges, sliders, and wheels, but there can be more complex implementations like actuators and controllers. Authoring rigid bodies and joints involves connecting pairs of rigid bodies with constraints to form arrangements that can move free and/or can be controlled by an agent. This process is interactive and can be challenging. However, it becomes more intuitive with experience. In this video, we will demonstrate a simple case by making the doors of a building functional, allowing for the emergence or natural interactions with the environment. We start by creating an architectural project from Unreal and making it a static rigid body scene actor. For more details, refer to Video Newton plugin for Unreal, Part 3A, Authoring Collision Shapes. The building contains 2 sliding doors at the back and 2 swinging doors at the front. Open the content browser. Navigate to the building folder and create a new actor blueprint. Name the blueprint, slider door, or another appropriate name. Double-click the blueprint to open the blueprint editor. Add a Newton joint slider component. This will simulate the sliding door mechanism. Add a Newton rigid body component as a child of the Newton joint slider. This will represent the door physics. Add a static mesh component as a child of the rigid body for visualization purposes. Assign the appropriate static mesh asset and materials to the mesh. Select the static mesh and add a Newton collision shape. Choose convex hull for simplicity. On the rigid body, enable Show Debug to visualize the collision shape. Assign a mass value. Around 30 kilograms works well. Select the Newton joint slider component, enable Show Debug, and activate limits. Set the joint limits to control how far the door can slide. The sliding action will be simulated by a supercritically damped proportional derivative sprint damper system. This just means a spring damper with a high damper constant. Compile and close the blueprint editor. We now move to the scene and replace each static back doors in the building with a new sliding door blueprint instance. For the second sliding door, since both doors are symmetrical, you can simply rotate the first blueprint by 180 degrees. Ensure the blueprint instances are parented to the Newton scene actor representing the physics of the building. Now we have a building with 2 functional sliding doors. However, we still need to add logic to open and close these doors. There are several ways to implement this functionality in Unreal. In this example, we will use a trigger box volume that detects when the player enters or exits the area and triggers the opening and closing of the door's events. After placing the trigger box to cover the volume around the sliding doors, with the trigger box selected in the outliner, open the level blueprint. Right-click and add the On-Actor Begin Overlap event. Check that the other actor pin is a character. From the true output, collect an array of all the sliding doors actors inside the volume. Iterate over the array of sliding doors, and for each door, access the sliding component. Set the target position to the open position. Compile and test the level to ensure the doors open correctly when a player enters the trigger volume. For closing the door, we just add the on-actor and overlap event, and we duplicate the same script, except that now it's set the slider to the closed position. With the trigger box selected, add the on-actor and overlap event. Duplicate the existing sliding door nodes. Connect the new nodes to the end overlap event. Set the target position to the closed position. Test the level again to ensure the doors close when the player exits the trigger area. Repeat the same process for the front door, but this time use a hinge joint. If everything went right, we should have a fully functional building with interactive doors that open and close based on player interaction. The process is the same for other building features. We can add cabinets, feature lamps, windows, almost any part that is expected to be attached but that can have some degree of mobility. We can even try some gameplay puzzles already. In the next video, we'll cover authoring articulated moving objects. Thank you for watching. Later.